All right, advanced math. This is the last section of chapter 4. Really, in this section, what we're going to do is just some application problems, real-world examples of how we can solve problems using trigonometry. So, really, these are going to be examples that really we could have done in geometry, but they're a little bit more involved. So that's why I saved them for advanced math here. So let's first write down these two terms. The first one is angle of elevation, angle of depression. Now I know we've talked about this in geometry. So the angle of elevation is going to be the angle through which the eye moves up from horizontal to look at something above. So essentially it's the angle formed by your line of sight and just some random horizontal line. Okay, so if you have to look up at something, so if right now if I'm looking right at you, okay, if I have to look up, I might have to move my neck, I might have to move my eyes, whatever that angle is formed by, instead of looking horizontally, okay, straight ahead, I'm going to be looking up. So however much I move my neck or how much I move my eyes there, that angle is going to be your angle of elevation. Okay? Angle of depression is very similar. The angle of depression is the angle through which the eye moves down from horizontal to look at something below. So really, the only difference between these two terms is that one, you're looking up, angle of elevation, you're going to be looking up, and then angle of depression, you're going to be looking down. Okay, so to kind of illustrate this, and pause if you need to, but to kind of illustrate this, let me tell you a little story about Jack and Diane. Okay, so a little story about Jack and Diane. So let's say, well, Jack and Diane, they were just two American kids growing up in the heartland. And, you know, Jack, he's going to be a football star. So, you know how football stars are. I think they can do whatever they want a lot of times. So, well, he takes Diane's chili dog outside the Tasty Freeze. Okay? So he takes her chili dog and he runs away from her and he runs up this hill here. So let me draw this hill. Okay? So let's say this is Jack. Jack ran up the hill. That's a different story, but that was Jack and Jill. Oh wait, that's Jack, so let's leave him. There we go. That's Jack. So he runs up this hill there. Diane, she's down here. She's got her chili dog stolen. She's gonna throw a rock up at him. She's not gonna stand for that stuff. All right, she doesn't take that stuff from him. She's gonna throw a rock at him because he stole her chili dog. So what she's going to do, she's going to, let's find her angle of elevation. All right, so her angle of elevation up to him, that's what she wants to calculate, see how much she got to put on this throw here. So she's going to look him right in the eye when she does this. Okay, she's going to look right at him. That's her line of sight. And then her angle of elevation is going to be the angle formed by her looking up. The angle formed by her line of sight and a horizontal line. So that right there is her angle of elevation. Okay. Hopefully that makes sense. Now, she throws the rock up at him, and it does actually hit him in the head. So Jack, he scratches his head, does his best James Dean, and then decides to throw the chili dog back at her. Because, you know, she just hit him in the head with a rock. So he's going to throw the chili dog back at her. And so he's going to try to calculate his angle of depression, right? He wants to hit her. So his angle of depression is going to be formed by his line of sight and a horizontal line. So that right there is going to be his angle of depression. Okay, so that kind of just talks about those two terms here. So what do you notice about these two angles though? All right, so one thing, essentially those angles are going to be the same. All right, now I don't know if you remember from geometry, but these are going to be alternate interior angles. So therefore they're going to be congruent. So the only difference is she's looking up, he's looking down. All right, so that was the story about Jack and Diane. That explains angle of elevation, angle of depression. And hopefully you got the reference there. All right, so let's move on. We're just going to do some examples here, really 3 examples. So here we go. Let's get this thing started. And guys, I have these printed out, so hopefully the sub has these printed out and passed out to you. So you don't have to write all this. But if not, go ahead and write it all. It says the angle of depression from a buoy to the top of the lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. All right, now I'm not going to try to attempt to draw this lighthouse. Let's just say, you guys know how I draw here. Let's say that's the lighthouse. Okay, it's beautiful. All right, there's my lighthouse. And we've got a buoy out here in the water, so let's say it's off the, this is the ocean here. We've got this buoy. All right, that'll be the buoy. So what we're saying is, from the top of the lighthouse, if you find the angle of depression to that buoy is going to be 6 degrees. And it actually tells us the height of the lighthouse too, so let me go ahead and mark that down, 130 feet. And let me try to draw the angle of depression. Now, this is key here, guys. What we need to do is draw the angle formed by if we have a person up here at the top of this lighthouse, their line of sight with what type of line? Okay, is it a vertical line or a horizontal line? And the answer is horizontal. So the line of sight looking down there at the buoy would be that line right there. And, well, a horizontal line, we need to draw that angle. So I'm going to draw just a random horizontal line here. That right there, that angle is going to be 6 degrees. All right, so that's what we mean by angle of depression. Now, guys, the very most common mistake people make is they try to say that right here, this angle that I'm pointing to, this guy right here, that angle. They try to say that's 6 degrees. That answer is, that is incorrect. Okay, that is not the angle of depression, because that's the angle formed by your line of sight in a vertical line. Okay, so guys, hopefully you can see what's going on here. If that's 6 degrees, and what I'm going to do is I'm going to form a right triangle here, because we can assume that the lighthouse is built correctly. It's built perpendicular to the ground. So we've got this angle of depression being 6 degrees. So what would the angle, let's say you were down here at the buoy and you were looking up the top of the lighthouse. What would the angle of elevation be? Well, the answer is 6 degrees. The angle of elevation and the angle of depression are going to be the same because those are alternate interior angles. Okay, and that was a geometry concept. So what we're trying to figure out is find the distance x from the base of the lighthouse to the buoy. Okay, x. That's what we're trying to figure out. So guys, this is just a geometry problem. We've got an angle, we've got a side. We can always find the other side by picking a trig ratio. Okay, trigonometric ratio. We've been talking about this whole chapter. So the question is, which trig ratio should we choose? Well, you got to look at what you have. So if you have 6 degree angle here, this is the angle I want to use. We've got the opposite side, and we want to find the adjacent side. So we got 3 trig ratios to choose from. Which one should we choose? Sine, cosine, or tangent? And hopefully you guys picked tangent. Okay? So it's going to be the tangent of our angle, 6 degrees. Now make sure your calculator is in degree mode when you're typing these in. But the tangent of 6 is going to be opposite over adjacent. So what's the opposite side? Pause for the answer. Okay, the opposite side is 130. What is the adjacent side? Hopefully you said x. And there we go. All we got to do is solve this. So this is just an equation. So how do we get rid of division by x? We want to get x in the numerator. We just want to get x equals. So how do we get rid of division by x? That's right, multiply by x. So we got x tan of 6 is equal to 130. Okay, we're almost there. Now we got x times the tangent of 6 is equal to 130. Now this is x times something. How do we undo times something? We want to get x by itself. So how do we get rid of tangent of 6 on the left side? We got to divide by tangent of 6. So x is going to equal 130 divided by tangent of 6. Make sure your calculator's in degree mode when you type this in. Okay, so all it takes is for you to type it in now. Let me do this real quick. Let me get my calculator out. Alright. So it's going to be 130 divided by the tangent of 6. It gives me, alright, so it gives me 1, 2, 3, 6 point. Does it say to the nearest foot? No, but let's just go around to the nearest foot. So that'd be 1,237 feet. Okay, let me double check that, make sure I didn't do anything wrong here. Yeah, that looks right. Okay. So that's the idea. Hopefully that makes sense. So just knowing those two terms, angle of depression, angle of elevation, is going to help us set up real world problems and solve. Alright, so that was nothing new. That's something we would have done in geometry. Okay, that's a little bit of an easier application problem. Let's move on. Let's move on to the next topic. To the next example, I should say. This one's a little bit more difficult. Alright, so let's look at this guy. So, it says, from the top of a 100-foot building, a man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Alright, so draw the picture first. So pause here and draw the picture. And then play it from here on out. I'm going to go ahead and get this thing started. So I'm going to draw it. Here it is. So we got a guy at the top of a building. Let's say this is the building. Again, here's my guy at the top. Alright. Let me fix that. Alright. Let's make it right here. Alright, so he's at the top of this building. And again, you don't want me to draw a car. So here's my car. Alright, I know that's kind of lame, but I can't draw cars. I can't draw anything really. Stick figures is about it. So that's my car, and it's traveling toward the building. Okay. And by the way, this is 100 feet. It tells us the building's 100 feet tall. Okay, so what's happening is the angle of depression of the car changes from 22 degrees to 46 degrees. So actually, I'm going to draw the car in two different positions. So this is my beginning position, and the car is going to be moving closer to it. So that'll be when the angle of depression changes to 46. Okay. So I'm going to draw two different triangles here. Actually, you can think of it as three different triangles. But so guys, if I wanted to draw, let's first draw the angle of depression down to the car initially. Okay, at its first spot, at its first position. So if you're looking down at this, that's your line of sight. Okay. And remember, the angle of depression is the angle formed by your line of sight and a horizontal line. So if I draw a horizontal line here, let me draw this in blue. That would be a horizontal line. This is going to be 22 degrees. Okay. All right. Now, if I look down at my line of sight to where the car is later, okay, when it moves towards the building, okay, that angle of depression, the whole thing here is going to be 46 degrees. That whole thing, right? That whole angle is going to be 46 degrees. So hopefully you can see what I'm going to do here, guys. Again, I'm going to form right triangles, but I'm going to have two right triangles. All right? We're going to have a bigger one and a smaller one. And again, you're allowed to assume that the building is built properly, perpendicular to the ground. Okay. So if those two are my angles of depression, you guys tell me, or try to answer this, what is that angle going to be, this first angle of elevation from the car up to the building? All right, so the one I'm pointing to here, hopefully you got it, 22 degrees. Okay, it's going to be 22. All right, so this angle of elevation is going to be 46 degrees. Think about that, guys. Let's say you're in the car. If you start here, if you start a further distance out, if you're getting closer to something, a building where you're looking up, okay. If I get closer, I'm going to have to look higher up. Okay, the angle of elevation is going to change. It's going to get bigger. Okay, so if I take a step back, I don't have to crank my neck as much to see the top. Okay, so hopefully that makes sense. The closer you get to an object, if it's above you, the more you have to turn your head to look at it. All right, that's pretty common sense there. So let's go ahead and try to solve this. Now, there's a couple variables I need to figure out. Okay, not really figure out. I need to just label. Okay. Yeah, I will figure them out in a second. So let's label these variables first. So what are we trying to find? Well, it says how far does the car travel? So hopefully you know that that is what we're trying to find. Let's just call it x. Okay. Now, there's another thing that might be useful to label, and that is this distance, how far the car actually is from the building. So let's call this d. All right, just the distance from the car to the building. Okay, so here's what I'm thinking, guys. All right, so hopefully this makes sense. Just bear with me here. But what I'm thinking that we can do here is if I can find, and just bear with me, if I can find this whole distance, okay, the whole thing, so originally how far the car was away from the building, all right, initially. If I can find that distance, and if I can find this d distance, okay, then all I need to do is take the one here, the one in red, minus d, and that will give me x. Okay? So there's more than one way to set this up. Let me just think of how I want to set this one up here in this problem. Okay, yeah, I think I'm ready here. So let's first, this whole thing right here, we could label a new variable if we wanted to. But let's say we didn't want to label a new variable. Let's say we just wanted to combine the two that we already have. Wouldn't this be x plus d? Is everybody okay with that? The whole thing is going to be x plus d. Alright, so here we go. Let's try to set up a ratio now. So again, just looking at this, let's look at the big triangle first. Let's try to figure out what x plus d is, this whole thing. Alright, so in order to do that, well, which trig ratio should we use? Well, if I'm looking at the big triangle, I need to look at this angle right here, 22. That's one of the angles of the big triangle. Okay, so if we use that angle, well, again, if you've got 22, we know the opposite, don't we? And we want to find the adjacent. So therefore, we should use the tangent ratio. So the tangent of 22 is going to equal opposite, which is 100, over adjacent, which is x plus d. Okay? So hopefully that makes sense. Well, how about we... That's the first thing. All right, so we'll stop right there for right now. We really can't solve this. We've got two variables with one equation. So I might need a new equation to figure out what d is. Okay? So let's do this. Let's set up a new equation to figure out what d is. Because hopefully this makes sense. I can't solve this yet. I've got two variables. Okay? So let's wait to solve that until we get one variable. If we figure out what d is, we'll be able to plug that in there, we'll be able to substitute, and then we just have one variable we can solve for. Alright, so here we go. This is going to be tangent. Sorry, I'm giving stuff away here. So the other equation I could set up is maybe just find d. Well, d is part of the smaller triangle, okay? It's part of the 46-degree triangle. Sorry. Let me just highlight it here. It's part of this triangle, right, the one in red that I just highlighted. Okay, so d is a part of that, so let's use that triangle to try to figure out what d is. Well, we got to use a trig ratio again, because we have this angle, we have a side, we've got one missing side that we don't have. So what trig ratio should we use? There. Well, it's still going to be tangent. It's going to be the tangent of 46, and that's still opposite over adjacent. So opposite is 100, adjacent is d. So we just got to solve that, and when we solve that, we're going to plug our d back into this equation. Alright, so here we go. So what I'm going to do, multiply both sides by d. So we got d times the tangent of 46, and that's equal to 100. Okay, and then in order to get d by itself, we have to get divide by tangent of 46. So d is going to equal, give me a second, let me type that in. You guys should be typing this in on your calculators. So we got 100 divided by tan 46. Make sure your calculator's in degree mode, and you get 96.56. Okay. Let's just, sorry, 96.57. And round it correctly. Okay, so what I'm going to do is I'm going to plug that back in to my original function. All right, so here goes. We got tangent of 22 is going to equal 100 over x plus 96 point, let's just call it 96.6. All right, so guys, how do we solve this now? We want to get that denominator off the bottom, don't we? So how do we get rid of that denominator and move it to the other side? How do we undo division? Well, we multiply. So I'm not going to have much room to show this, but I'm going to multiply both sides by x plus 96.6. All right, so I multiply that side by x plus 96.6. And then we got times tangent 22. And that's equal to 100. Because when I multiply this side by it, it's going to cancel the denominator. Okay, that's why we chose to multiply by it. So now what you can do from here, you could distribute the tangent of 22 if you want to. I'm not going to stop you from doing that. You can do that if you want to, but I'm going to choose to do something different, I should say. I'm going to move the tangent of 22 over. Well, this is going to be times tangent 22, so how do we undo times tangent 22? We divide it. So x plus 96.6 is going to equal 100 divided by tangent of 22. Let me type that in. Okay, this is going to be 247.5. Okay, and then all you got to do is subtract 96.6. Those cancel, so x is going to equal, we got 247.5. Let me just subtract 96.6. Answer 150.9. I think this answer is in feet. So that's how far the car's traveled. So actually, guys, with the way I chose to set it up here, I called this x plus d. I didn't have to subtract it at all. I mean, we could do that. So x plus d would be, it would have been the 247.5, and then we subtracted d, which was 96.6, and that gave us x. Okay. So I'm going to stop this video right here. I want to try to make these videos a little bit shorter. So the next video, I'll just do one problem, and that'll be all for this section. This is how you apply trig functions to real-world examples.